So let's understand accuracy and precision. So what's the difference between accuracy? What does it mean if someone says you are accurate or you are precise? So we need to understand the difference. Now, starting with accuracy. So accuracy is simply the degree of closeness of a value to a mean value. So how close is the value to the mean? That is what we call accuracy. Now precision is just how close individual values are to each other. So this is precision and this is accuracy. For example, imagine you are performing a titration. I know we can remember some titrations, or say you are measuring the mass of this object using a beam balance, and a person A is measuring this same object. He finds that the mass is 2.1. This is in kg, and then again he finds that it's 2.2, and then he also finds that it is 2.0. And then another person comes to find that one value he measures to be 2.1, another one he measures to be 2.9, another one he measures to be 2.3, and then another person measures values to be 1 to be 4.0, another one finds to be 4.1, another one finds to be 4.2. Now we need to find out the actual value of this thing that you are measuring is 2.0. This is the actual value. Now I want to find out which of these people are precise and which one of them are accurate. So when you're talking about accuracy, you are going to compare each of these values to the standard value. So if you see for person A, 2.1 is very close to 2.0. 2.2 is also very close to 2.0. 2.0 is also like exact. So this person is accurate. Why have I said is accurate? Because if you compare each of these values to the standard value, you see that the person is what? Very accurate. Now, when you are determining accuracy, you don't use each of these values. What you are going to do for you to determine accuracy is get these values, add them, and then divide by how many they are. So 2.1 plus 2.2 plus 2.0. That is going to give us about 6.5, and then divide how many values are there. There are the three of them, and then divide by 3. That answer that you get, then compare it to this one. If they are very close, then you are accurate. Now when you look at these values, are they close to each other? Well, 2.1 is close to 2.2. 2.2 is close to 2.0. 2.0 is close to 2.1. So because each of these values are close to each other, then this person is what? Is precise. So we say that this person is both precise and accurate. Now look at this person here. The values we've got 2.1, 2.9, 2.3. Is 2.1 closer to 2.9? Not really. So this person, because the values are not near each other, so this person is not precise. Why? The values are not close to each other. Now add 2.1 and 2.9 and 2.3, and then divide by 3. Compare that value to 2.0. That will not give us a number that is so close to 2.0. It will give us maybe something like maybe 2.5 or 2.4, and that number is not close to 2.0. So when you're talking about being precise, you are going to find the mean of these values. That mean that you get now, compare it to the actual value. If it is very close, then you are what? You are precise. If it is not close, then you are not precise. So this one, I mean, then you are accurate, not precise is accurate. So this person is not accurate and is not precise. Accurate, I'm saying find the mean. That mean that you find, now compare it to this value. Now look at this person. Are the values close to each other? 4.1, 4.0, 4.2? Yes, they're close to each other. This person is what? Precise. Now, are these values, if you find the mean, going to be close to 2? Not really. So 4.1, 4.0, 4.2, if you add them and then divide by 3, they'll give you 4 point something, and 4 point something is far away from 2. So this person is precise but not accurate. So being precise is mostly caused by the instrument that you are using. Imagine when you are using this balance. Before you can even put anything on this balance, it is already showing that there is 2 kg mass. You've not put anything, but it is showing that there is a 2 kg mass. So it doesn't matter the person who comes to use this balance, whether it is a professional, a doctor, an engineer, it will also show these same wrong results. That is because the fault is not with the person, but it is with the instrument. So the fault in the instrument causes your work to be unprecise. But when you're talking about accuracy, accuracy is caused by the person himself. Imagine the one who is performing the work doesn't know how to read. Maybe instead of you reading 2.4, you get to read 2.7. So it is yourself who doesn't know how to read. So that is going to cause inaccuracy. And inaccuracy is also caused, for example, maybe say you are performing a titration. Remember that in a titration, there's what is called a end point. When you have just added enough acid to the base to cause neutralization. Now, if you add more acid to the base so that the color changes very much, that is going to make you to be inaccurate. So, inaccuracy is also caused by what? Just your inexperience in working with the instruments. So, this is about accuracy and precision, and these ones you need to know very much good. You need to know them. So from here we also have what is called types of errors. So I've got determinant errors and indeterminate errors. Okay, determinant and indeterminate. So there are some errors that you can just determine direct and some errors that you cannot determine direct. So when you're talking about precision, these are caused by indeterminate errors. Like you can't determine the errors very sorry, these are called precision is caused by determinant errors. That is because the error can be easily identified, and for determinant errors you can easily correct them. For example, you are going to say that the instrument is just wrong, so you get to correct the instrument. Maybe you need to just tune it a bit. But for inaccuracy, it is caused by indeterminate errors. You can't determine them. Those errors cannot be determined. It is just part of human being to make those errors. So those are the errors that cause inaccuracy. For example, it is just part of us to, like when you're performing a titration, you can't just be so exact. You use the exact volume. Or maybe when you are getting to read, say this is a meniscus, this is a test tube, and then the volume is like this. It's reading like this. There is a 4 here, and then there's a 3 here. A person can end up reading 4 instead of reading. So when you are reading, you read the lower portion. You don't read where the maximum is. So you read where the minimum is, that point. That is called the lower meniscus. So such things, just errors in reading, because here someone can come and read maybe 3.4, another one will read 3.5, another one 3.6. So it is not like you don't know what to do. It's just part of us to make that mistake. So that is a indeterminate error and we can't avoid it. So this is about errors. So indeterminate errors, the other name is called random errors. Those errors that are just random, they just happen, you don't plan for them. And then determinant errors, they're also called systematic errors. They are more part of the system, and it is very difficult for you to avoid. That is indeterminate errors or random errors are very difficult to avoid them, but systematic errors can be avoided. So from here, This is what we need to understand. Apart from this, the last thing that we need to understand when it comes to this point is just other types of errors, that is absolute errors and percentage error. When you are talking about an absolute error, it is given as absolute true value minus recorded value. This is how you find the absolute error. For example, say you have got this calculator, its mass is 2.1 kg, and then when you are measuring, you find the mass as 2.0 kg. So to find the absolute error, you're supposed to subtract 2.1 from 2.0. So this is going to be 2.1 minus 2.0. This is going to give you 0 0.1. So this is the absolute error. Now we are putting this in absolute because whether you start with 2.0 minus 2.1 or 2.1 minus 2.0, the answer is always supposed to become positive. If you start with this one minus this one, the answer is going to be negative. And if you put a negative value in absolute, it's always going to come out positive. Absolute means anything that comes outside this should always be positive. So that's the meaning of, that's why we're also calling it absolute error, because we don't want it to be negative. And then the other one is called relative error. Now relative error is just found by saying absolute error divided by true value and then multiplied by 100%. Well, this one I've put 100%, then it is called percentage error. Otherwise, percentage relative error or just percentage error. Otherwise, just relative error itself, you don't put the 100%. But if they've said percentage error or percentage relative error, then you multiply by 100%. So for example, the same one I gave us 2.1 is the actual mass, and then you measure, you find 2.0 kg. So to find the relative error, if you subtract 2.1 minus 2.0, you're going to find what? 0 0.1. And then divide by the true value. Which one is the true value? We've said 2.1 is the true value. And then multiply by 100. That is going to give us the percentage error. So every value that we are going to calculate is the percentage error. So that is how we basically calculate the percentage error and also the relative error. You also need to know that for just the absolute error itself, you can also calculate it in another way when you don't have a true value and you don't have a recorded value. For example, when you have got 2, this is our number. Let's say it's 2 kg. The absolute error in this one is always look at the number of decimal places. There's no decimal places, just the whole number, so just 1 over 2, which is also 0 0.5. This is the absolute error in this value. And then when you've got 2.0, how many decimal places are here? Only one decimal place. So the absolute error is going to be 0 0.1 over 2, which is 0 0.05. When you have got 1.201, look at how many decimal places are here. How many are there? 1, 2, 3. So write just a number 0 0.001. There should be 3 significant figures also here. 1, 2, 3. No, these are 4. So suppose you write it as okay, you look here 1, 2, 3. There are 3 decimal places, so we're supposed to have 3 decimal places here. Just make sure that the last number is going to be a 1, and then these are supposed to always be zeros. And then just divide that answer by what? By 2. So the absolute error is going to be 0 0.00005. If it is 2.110010, just look at how many decimal places are here. 1, 2, 3, 4, 5, 6. So therefore the absolute error is going to be 0 0.00000. This will be 6. 1, 2, 3, 4, 5. The sixth one should be a 1, and then divide by 2. So this is going to be 0 0.00000012345 6, and then a 5 at the end. So that is how we find absolute error if they've not given you a true value and a recorded value. So to find the relative error, just for this one, just get the absolute error, which is 0.5. The true value is what? Is a 2. I know you did this one at grade 12 in mathematics. And then if it is percentage error they are looking for, just multiply by 100. For this one, the relative error, just get this one over 2.0 and then multiply by 100, just like that. So that is basically how we get to find absolute errors and also percentage errors and relative errors, accuracy and precision. So that is all going to be for now.